One of the most important restrictions that are placed on our data tables is that every row or record must be uniquely identifiable. There has to be one piece of information that you can use to identify exactly one record with absolutely no ambiguity. This particular field is called the table's primary key, and it provides the unique value we rely on to link data across related tables. Let's suppose that one of our customers has an issue with a product that they ordered. We can go to our orders table and look up the information about that transaction, but how do we find it? The customer first gives us their name, which will show us all of the transactions that they've completed with us, and hopefully that's a bunch. This is good to know and it gets us close, but it doesn't find us a specific transaction. They could tell us the date they placed the order, but again, that would also return all of the other orders placed on the same date, and not identify their own order specifically. This is why we have something like an invoice number column. It helps us uniquely identify a specific transaction in our table and serves as the primary key to our invoices. Think of all of the numbers that are identified with you personally. You have a national ID number issued by the national government, a driver's license number issued by the Land Transportation Office, which a government agency, a bank account number, a loyalty club membership number, and so on. All of these numbers are essentially primary keys in somebody else's database system that are used to uniquely identify you as a separate person from everyone else that might share your name. Primary keys are incredibly important, and one of the core components of a relational database. Because of this, there are several rules put into place when it comes to creating a primary key. The first rule is that a primary key must be a unique value. After all, that's the entire point of a primary key. Second, it cannot be left blank. It absolutely needs to have a value. Third, it needs the value created as soon as the record is created. There's no opportunity to fill in part of the record and then come back and give it a primary key later. It all needs to happen at the same time, and fourth, primary keys cannot be changed once they're created, except in very extreme cases, and with a lot of careful planning. To identify keys, we'll look for fields whose values are dictated by other fields. In the world of database design, this is called functional dependency. Looking back at our invoices table, the customer, date, product, method of payment, and so on are all dependent on the invoice number, and will change from invoice to invoice. In this case, the invoice number is a perfect primary key. Sometimes there will be a value that we're already keeping track of like this that meets all of the requirements of a primary key. It's likely that we're already keeping track of a receipt number if we're using pre-printed receipt books, which is a great choice for a primary key for our invoices table. These are called natural keys, values that are already present in the data that can become the primary key. However, if we don't find any columns that are suitable, then we'll need to create a new column in our table specifically to take the role of the primary key. This goes by the name of surrogate or a synthetic key. It's often some sort of serial number or something that the database generates automatically as records are created. Surrogate keys will often not support any specific business need and are useful only to the DBMS. Here's an example. If we look through our student table, we don't see anything that jumps out as being suitable for a primary key. The name fields certainly won't be unique, as we'll probably have lots of students named Mark or Mary. We'll also likely have students that share the same last name. It's also not inconceivable for two different students to live at the same address, or share the same phone number. Not seeing a suitable candidate for a primary key, we'll decide to create one for the table by adding an additional column. So what data are we going to put here? Well, in this day and age of privacy concerns, it is not ideal to ask them to share any government-issued identifiers with us. So we'll go ahead and create an internal numbering system on our own. You might already have a number that you use internally, but if not, we'll just create one now. And since this isn't a number that we're particularly interested in, we'll just let the DBMS assign values as new records are created, by taking advantage of the internal auto-incrementing feature of the system. In this way, each student will get their own unique student ID assigned to them as soon as their record is created in the database. primary keys are typically only a single field or column in the data table. However, they can also be composed of two or more columns, a situation that's called a composite primary key or a concatenated primary key. When two or more columns combine to create the key, each individual column can contain duplicates, but the combination of values must be unique. In certain situations, this can be a very useful way to store your data. Let's take a look at an example. Suppose you work for your city's fire department and need to keep track of the fire hydrants in your area. One of the things that you want to keep track of is the location of each fire hydrant, by storing the latitude and longitude. If we set up a data table with an auto-generated or a surrogate key column, something like the fire hydrant ID that I have here on the screen, then we'll have a situation that looks like this, where each hydrant gets a new ID number and the latitude and longitude values are associated as additional columns. The problem that arises is that there's nothing in this table structure that prevents me from creating two hydrants in the same location, something that would be impractical to do in the real world. For instance, this table indicates that hydrant number 2 and hydrant number 1 are at the exact same latitude and longitude. While there's clearly an error here, the rule that a primary key cannot be duplicated hasn't been violated. So as far as the database is concerned, this is a completely valid situation. Instead, what we can do is create a composite key saying that it's the unique combination of latitude and longitude that provides the primary identifier for each hydrant. Now our database is protecting us from invalid data entry. We can have lots of hydrants in a row at the same latitude, and lots at the same longitude, but only one hydrant at any specific intersection of a latitude and a longitude. Now if needed, we can add back an ID or a name column to make each hydrant easier to identify in an annual report, for example. But the primary way the database will keep track of our hydrants is through the composite key of latitude and longitude. Finally, primary keys provide the main connective tissue through which our databases will keep track of relationships. Once we know the primary key for a specific customer, for example, we can go back to our invoices table and replace their name columns with the same unique identifier. What is called the primary key in the customers table becomes something called a foreign key in the invoices table. So that's what you need to know about primary keys. They provide the unique identifiers for every record in every table in our database. It's through the use of these keys that we're able to make relationships to other tables, and ensure that the DBMS is able to keep our network of connections across the entire system. To sum up, if you find that your data tables don't have a suitable key that will uniquely identify each record in the table, then you'll need to add one using some sort of serial number of auto-incrementing number. Finally, we'll use those keys to provide more specific linkages as we further develop not just the two tables that are related but by what specific fields they'll relate. So for every relationship in your data model, ensure that there's a copy of the primary key field from the parent table in each related child table as the foreign key. That's it for now. Thank you for watching.